Someone's already recording by the looks of things.
Well, Zoom is recording.
Yeah, so.
Please talk me through.
So our computer's just gone to sleep. So I've got there.
Do you want me to?
Yeah, just give it a bit of a wiggle.
Yeah. I'll put the first slide up.
Press two. Yep. That's good. Yeah, yep. So we're just, I don't know where their remote is because it's the in-house projector. I haven't seen it for a while. No, this is the first time I've ever done a job here. Yeah, we live at the Ville. That's like where I feel like I never leave. They're in the entertainment centre. I feel like I'm there all the time.
So what do? Oh my god. So what do people want?
So what they're seeing right now. Do I have to do it from over here? Can you hear me all right if I stand here? But the recording might. Okay. I've been told. How's that? Is that better? Thanks, everyone. Welcome. For those that don't know me, I'm Ian Walker. I'm the General Manager at the Reef Authority. And part of my program of work is this particular bit of work, which is our marine monitoring program. So I have, I guess, this piece of work plus a few others to keep us busy at the Reef Authority. But before kicking off, can I just thank Kay and Martina for pulling this together, and just also thank our partners involved as well. I'd also like to start by acknowledging the traditional owners of the land that we're on, the Woolgooroo Kabar people, and just pay respects to elders past, present and emerging, and recognise the significant role that our traditional owners have played in shaping the land, sea country we're on, and recognise the vast number of traditional owners who play a role in managing sea country and work with us in the management of sea country. Just wanted to highlight a little piece of that jigsaw earlier this week, the traditional owners released their traditional owner implementation plan as part of the 2050 plan. And that was a significant piece of work because it spoke to their aspirations around how their country, their sea country, is managed. And it goes to both the management activity, but also to our monitoring programs and how we need to strongly engage in all aspects of our work with the traditional owners in whichever part of sea country we're working on. So I just really wanted to emphasise that. This program and this piece of work is critical for us collectively. It informs everything that we do. And I think that goes without saying that our monitoring programs are the foundations of our decision making. So this monitoring program and many others form important pieces of information that we're actually now using and will continue to use in our Outlook reports. And those that are not familiar with Outlook reporting, it's a report that gets produced by the authority every few years to really describe the values, threats to the reef, and it's this information and many other pieces of information that informs that work. And I think it's really a credit to the group of people here around how this program has evolved and continues to evolve. On that note, I'd just like to thank you all for attendance. Look forward to engagement in the workshop today, and I'll hand back to Kay, Martina to get into it proper, but welcome and enjoy the workshop.
Yeah. Well, thank you everyone for coming. Just before Kay starts, I would like a couple of housekeeping things. Toilets just across the room, that way. And people online, please make sure you have your camera and your audio off. And if you have any questions, please put in our chat. Look, this must be a momentous occasion. I actually have notes. Okay. I must admit that this morning on the ferry coming across, and by the way, it is spectacular out there today. It is absolutely sparkling. And I use those moments every day as my motivation for my role here in MMP. It's really great motivation and thinking time. But what was I going to say? Oh, I sat down and read my notes and realised for the first time that I've got some nerves. And this is unknown for me usually. People that know me, I'm pretty garrulous, but it's because we've achieved so much in such a short time with our team, with Martina and with our partners, that I realise this is quite a momentous occasion. So, getting on with it and needing the glasses. Welcome and thank you all for your attendance. Those who have made the trek to be here in person, it's really great to meet you. It changes the way we also relate online. And all those online, thank you for making the time to be here as well. I'm hoping to hear your thoughts today. So as we progress, we've got discussion time, we've got the presentations. We're going to be a little bit flexible. We'll try and keep to the schedule, but flexibility to allow good discussions to occur. Thank you, Ian, for opening. This is the very first MMP Symposium with the new MMP team at the Great Barrier Reef Marine Park Authority. As you guessed, that's me and Martina. And a big shout out to our new director of our Science for Management section, which is where MMP sits, Chloe Shawbull, for actually being so supportive for us getting here. Martina and I only came together in January this year, as many of you will know, but we quickly managed to forge a pretty strong team. I'm a bit excited and I'm a bit amazed at what we managed to do in a short time. What we set out to do was quickly do a review of where we were up to, where the program was up to, and we set some new improvement processes or improvement plans. The success so far is not only based on our combined and different research and management background and experience, but also critically through our shared dedication with our MMP partners. Their collective experience and probably the most important thing is our partners' willingness to participate in a process of change for program improvement. It's hard to do, new teams coming into long established programs. So we thank you for giving us the time of day and letting us find our feet there. We were also very fortunate in our timing. A new government came along and we were offered an opportunity, thank you, a big shout out to DQ there, to submit a funding proposal to actually fund these improvements from the new government's budget promise. Now, I doubt I'm going to be taking everyone to Tahiti. However, it is something to work with, and we haven't got anything actually in our coffers yet, but we're hoping it will come, and it's already allocated with the improvements that we've already decided upon or trying to work with. We're trying to address some of the current gaps in the program, both geographical and operational, and to incorporate advancing technological opportunities. And we're going to introduce some of this progress to you as we go along today. But the purpose was firstly to bring the MMP program in line with the Paddock to Reef program scheduling and review process, and addressing our role as the reef component of the Paddock to Reef program to help identify the outcomes of the incredible not only time and money, but effort by all involved on the land, on the coasts, farmers, corporations, the OGBRs, the DES, the DAF, the DQ, the groups, the volunteer groups, all of those people throughout the Queensland catchment area working to improve water quality to entering the reef. The buck stops with us in that sense. We're the team that is actually reporting on what outcomes are occurring. And you're probably aware the MMP provides information for the reef water quality report cards, which are interpreted as grades, which help track the progress towards meeting the water quality targets. So So we all fit under the Water Quality Improvement Plan, the Reef 2050 Plan, etc., etc. If you want all of that complexity explained to me, talk to Martina. Secondly, we wanted to initiate marine monitoring tools with the purpose of presenting the water quality, coral and seagrass condition monitoring results in a more timely, accessible and useful manner to all. Okay, for management and research purposes also, of course, but currently we report annually in the technical reports. And Martina's going to talk to this, what we've put in place about this in a moment. And these are fantastic documents. We couldn't do without them. They support our decision-making based on scientific evidence. However, I'm suggesting they're perhaps not the most accessible format for information, particularly as these reports currently come out approximately a year after the monitoring year. So Martina led a project to actually find and develop an information tool to get the information out there so that we can just flick the button on our laptop and get the information. So Martina, you're going to be talking to that. Thank you very much. That's your bit. That's not meant to diminish the need for this work and the scientific evidence and the technical reports. But the idea is to find ways of getting information to where it's needed, in formats that it's needed in, to enhance the awareness of this information being available and the effective use and understanding. As such, we're meeting here principally today to hear from our MMP partners about the latest inshore Great Barrier Reef monitoring results for water quality, corals and seagrass condition. Nice pictures, they're their last report covers up there. And also, sorry, I should say this, our partners do all the hard yakka, right? Our partners are the ones that are out in the field operations, sampling, analysis, interpretation of the results, collaboration, writing the technical reports, and they include AIMS, addressing the coral monitoring and components of the water quality monitoring, and JCU Topwater, addressing seagrass monitoring and components of the water quality monitoring, including Cape York Water Partnership. Big shout out to Christina. She's trekked down with her teammate from Cape York today, so thank you very much. And they're doing the water quality from that rugged, remote, far north. There are also other community and volunteer-based groups, NRMs, TOs, TUMRAs, research and monitoring organisations that our partners engage with in their research and monitoring roles. And we greatly appreciate and glad to see some of you here today as well. That's fantastic. And you may hear more about this in the presentations, but if you don't, the idea today is to talk to us, is to ask questions, talk to the partners. Hopefully we've given you enough breaks during the day to do that, and find out about each other. Heads up, the results being presented today are not all a good news story. And this can be really challenging. Can be challenging to all of us, both personally and professionally. Many of us live, I do, in the inshore region or along the coasts. We snorkel regularly. I've been involved in monitoring reefs around Magnetic Island, I'd hate to say, since the early 1990s. Showing the age there. I've run research in the Orpheus Island Research Station looking at nutrient impacts on corals. I've looked at what we used to call back then solar irradiation impacts on corals around Magnetic Island, and yet they bleached when in my project because of freshwater inundation. There you go. So what we're seeing is we see multiple impacts all through the inshore region. I'm currently watching my favourite reef try to recover from bleaching, and it is challenging. Every day I go to snorkel that reef, I gird my loins because I know I'm going to feel it. But it's also challenging in a really positive way. It reinforces why we need to be monitoring. Simply put, to know what's going on in the marine park, we need to be maintaining rigorous monitoring and striving to find ways to manage our program better, more cost effectively, and importantly, finding ways to be most influential through effective communication and the management and best practice outcomes of our monitoring efforts and results. As I said, Martina's going to speak to this, but I'd like us to consider the challenge for a moment in respect to the Reef Authority's new logo campaign. See the reef, love the reef, protect the reef. And it's absolutely great that we have identified that we need to bring the community along the journey with us. But I'm going to add to that. In respect to the Reef Authority's role in protection and management of the Great Barrier Reef, we also need to speak for the reef. Our communication section would probably rap me over the knuckles because they put it much more formally. They say that we are the authoritative voice of the reef. But I think it's more than that. The MMP is the longest running water quality monitoring program conducted in tropical waters in the world. We had the longest period of continual data to interpret trends, identify impacts from bleaching, cyclones, flood events, to identify areas of greatest risk and resilience in relation to recovery times and location. And it's currently the program used to identify the possible outcomes for all that work being done on our lands and coasts, catchments and wetlands to improve sediment, pesticide and nutrient runoffs. And hence, we are in the position to be speaking in this whole arena for the reef. I've heard it says it takes a community to raise a child. I personally thought it was a lot of patience, but anyway, it's going to take a community to protect the reef, to raise our collective recognition of its importance to our community, our way of life, and particularly this inshore region, which seems to have been overlooked in our reference to the reef, the use of language. It's not intentional, but that is the outcome, I think, of changing that language without perhaps appropriate interpretation. It's also going to take this community, our collaborative community, and the communities we live in along the Great Barrier Reef to achieve this. And as I said, this is the language. It's all about the language we use to describe the reef and how we communicate the results we're finding in relation to the importance of these inshore habitats, not only in ecological terms, but for our coastal human communities, as well as to the entire marine park. So where am I heading with all this? Next slide. We're speaking for the reef. So yet again, this is just another one part of our communication strategy of how we're going to start communicating what we do, what MMP does, and what happens in that inshore area. We've also asked our partners today to have more to their story. We've asked them to address two themes from their program perspectives in their presentations. We've asked them, firstly, why is sustaining the health of the inshore region so important? And secondly, why is it important to maintain a program of rigorous inshore monitoring? And wait, there's more. We have two guest presentations today as well, straight after lunch, to help us consider how we're doing this and why we need to be doing this. So straight after lunch, we have Jenny Scarrett from CSIRO. Thank you, Jenny. Talking to us about e-reef modelling, how this intersects with monitoring, and fundamentally why we've been able to reinitiate pesticide monitoring this year. Thank you, Jenny. And those that have got a question, I know there's Bree somewhere out there with her question about, I didn't know that it stopped. We'll talk about that later, right? But that's bravo to you and the people and our partners who have just been deploying for us as well out there. Thank you, everyone that's been doing that. We're actually doing it. And Steve Lewis from Tropwater is going to be presenting, I think, on how we know water quality entering the reef and in situ water quality has changed in the reef environment with the use of coral coring. Something like that, Steve? Around that topic. Okay, brilliant. Okay, so this conceptual diagram. So this is from an MMP perspective. Our community, our Queensland community, spends most of their time in the Great Barrier Reef in the inshore region. We're fishing, we're sailing, jet skiing, swimming, bird watching. I've asked her to change the jet ski's trajectory there on the left-hand side. There appears to be a dugong in front of it. However, we'll get around that. Just the complexity of marine park planning and management, right? Development. Okay, it's in development. I put in development there. Our seagrass meadows and our inshore reefs and associated habitats such as the mangroves and other wetlands, as we all know, they act as nurseries and habitats for numerous important recreational and commercial fish and crustacean species. Think prawns and the lovely red emperor. Inshore reefs provide stepping stones of habitat protection and food for fish turtle species making their way out into the greater reef environment. Turtles being the ultimate demonstration of connectivity between all of these habitats, laying on those coasts, laying on the beaches, and moving through all of those habitats throughout their lifetime. The inshore area is a critical habitat for these critical species, and as well as dugongs, so great significance to our TOs and our Indigenous people. A vast area of immense socio-environmental importance to our communities. Part of our collective past, our present, and our future. So it demonstrates connectivity between all the critical habitats of the reef, the coastal catchment wetlands, the river and creek entrances, through the inshore reefs, the seagrass meadows, playing their role to help protect and nurture the mid-shelf and outer reefs and filter that incoming water, water quality to the reef. And our current federal minister's favourite, blue carbon. Seagrass sinks carbon. So it is also a critical part of the blue carbon management of the reef. And we haven't even touched on the economic importance of the reef to both our Queensland community and our nation, and let alone the world. But something we don't speak about anymore often, yet it hasn't changed. And in fact, if anything, it's become more important with the more intense and frequent climatic events we're experiencing. These inshore habitats are not just ecological entities, they also provide us with coastal protection and stability. Just look at what happens to the beaches, the south of the GBR, and their erosion issues when there aren't inshore reefs to help protect that. We have bad enough problems here, but those reefs and those stable seagrass meadows help prevent erosion. Seagrasses are just like any other grasses. They're putting their roots and their stems underneath and creating a whole stable substrate that prevents erosion and scouring. I'm pretty sure I'm talking to the converted here. But we're not talking it anymore. We may know it, but I'm not sure our communities are actually looking at it holistically like this. So we need to be doing our work specifically, methodically, providing scientific evidence for sound decision making, but at the same time thinking holistically about what the outcomes mean and how we can communicate these effectively to, yes, our collaborative management, monitoring and research committees and communities, but also to our communities. So our communities that we live in. So they have the opportunity to understand the importance of the inshore region also and can make their own informed decisions. Hence my rave is over today. But I wanted to prepare ourselves today for keeping our minds open to the ideas and the presentations we're going to hear and actually actively participate, because we've got a lot of great hearts and great minds in this room, including online. I'm not forgetting you. Please make sure you put your hand up. If you've got comments to make, we'll be monitoring. And with great hearts and great minds, we're going to come up with new ideas about how to do things. And that's the only way forward. And with that, did I do it in time, Martina? Wow, thank you. I'm going to open across to Martina to talk even more, a little bit, to introduce one of our new communication tools that we definitely want to hear your feedback from. So thank you very much for your attention, and I'm sure you'll see more of me. Thanks, Kate. Just need to do this. I'll switch presentation, okay, don't worry. We'll get it. Oh, thanks, Kate, for this amazing introduction. I know you still call us a new team. We've been here for a year now. We're new-ish. So yeah, one of the things we've been working on is, as Kate pointed out, is how we communicate the MEP. She actually brought a report, which is not even the thickest one we have.
It's not actually accessible for a lot of people. So we had our first meeting with our partners earlier this year around March, and one of the things that they voiced is, come up with ideas on how to make those results more accessible. And so Kay and we have a lot of support from our colleagues in our section to develop a product that would make that happen. So this product is the MMP dashboard, as we're calling it. So what I'm going to present today, I'm going to talk you through why we felt the need, I guess Kay pointed out, to have this information out in a different format, in a different medium, and also do a bit of show and tell of what the MMP dashboard we're calling phase 1 is going to look like. And as Kay also pointed out, we are still looking for feedback, especially in regards to what kind of information people will be interested in finding or getting from the dashboard. So I don't need to remind anyone who's here and people online that came to the symposium. We all know the MMP monitors water quality condition and coral and seagrass health in the inshore region. However, what a lot of people might not be as aware is how we do this monitoring and how we, our partners. And I'm not going to go into details about methodology by any means. It's just that I want to point out to the time frame and the timelines of how the monitoring actually occurs. So our field work for the marine monitoring program happens pretty much year-round. So for example, for the 2022-2023 monitoring season, which is the current one that we have, 2 of our teams have already been in the field. So seagrass and water quality has already been in the field. So roughly for the seagrass is the first one there, the seagrass component, they're in the field from September to around June next year. For the coral team, they are usually in the field post-summer, doing the monitoring of the corals in dry season. And the water quality team, as Kay also pointed out, it's an effort from AIMS and JCU, so it's a joint effort there. It's a huge program. And they're in the field from around October to May. And for the water quality component of the MMP, there's also more field work and intense field work that happens during wet season. That includes what we call the event monitoring. So when there are big flood events, our teams are ready to go out and collect samples so we can analyze the effect of those flood plumes entering the inshore region and the potential effects on coral and seagrasses. So as you can imagine, we have 3 huge programs and we monitored pretty much the whole of the GBR, the 6 NRMs. And so there's a lot of data that goes into it. And you can imagine that analyzing all the data and doing all the QA/QC process takes time. After they analyze the data, they do the QA/QC process, they have to interpret the data, put those reports together. As I said, they're not thick, they're actually quite thick, piece of work. And then after that's ready, they're sent to us, and because they're scientific publications, there is a peer review process that goes with it. And after the peer review process is done, and we're happy with it, they address the comments from the reviewers, they send back to us. There is also a few steps to get those up and publicly available through our e-library. So that's how we have the monitoring component, but also the second component, which is getting those reports out in what we try to do in a timely manner, or as soon as possible. But those things do take time. So just to give an example, last June we just published the 2020-2021 technical reports. So as Kate said, it takes nearly a year after monitoring has ceased for that particular monitoring year. So what we wanted to do is to cut that timeline a bit shorter. So get those results, so important for management decisions, out and publicly available faster. The reports were still going to be relevant, that information was still going to have to be produced, and the reports were still going to be part of the MMP, an important part as well, so that's not going to change. But the partners suggested, can we find another way to get them out in a more timely manner? The MMP has been going on for 17 years. It's a long-term monitoring program. And so over the past 7 years, a lot of things changed in terms of how people access data. So that's another important thing that we need to consider. We all know that most of us will access data online. And so, I can't remember the last time I read a scientific book. In my scientific career, I would read papers and I would go online to get the data. And we also always try to find about, especially when we're talking about managing the Great Barrier Reef, the most up-to-date data. And MMP always has this issue that what's the latest of the MMP? And this happened this year, or the latest is actually 2020, 2021. So we didn't have the latest of what we're going to be presenting today back, in June. So what we want is to have those results out as soon as practical. And that will be determined by our partners. So when they feel that the data is ready to be published or made available, that's when the results will be made available. And another thing I want to point out is that there are different timelines for each of the programs. So some programs will probably require less time to do data analysis and, write those reports and interpret the reports because there's less data involved. And so they might want to release those results a bit before the other programs. So basically, we want also to release the teams from that constraints of the tight, the really constrained MMP schedule. So when the teams feel that they're ready to release the results, they don't need to wait for the other teams to do so. The dashboard will have some caveats, of course. Unfortunately, at this stage, it won't be able to be peer reviewed. However, we'll probably put a warning on the website saying, look, that is still to, technical reports still to be released, peer review process in progress or something like that. So that will be there. However, given that the MMP has been going on to say for 17 years plus, is heavily peer reviewed. The methods are robust, have been through an independent review already. And our partners are actually experts in their field. They are active scientists doing research. So we are very confident as an agency that the results that they sent to us, the results that you will be seeing today, they are reliable and they can be used for management decisions. And also they're not, at this stage, is not citable. So it's something that we are working on as well. It's something that's possible to assign a digital object identifier with a unique URL to the web page, so people in the future can actually have that to justify management decisions or even grant applications based on MMP data ahead of the reports, because the reports are citable. So having said that, we want the dashboard to be a place where we have a current content that is user-friendly, and you can actually get the data in a more timely manner ahead of the release of the reports, which we're also working on having them released earlier than happened in previous years. So having said that, so where will the dashboard sit? The dashboard will sit in the Reef Knowledge System. The Reef Knowledge System is, you can access through the Gabrumpa website, but if you don't know where to go, just Google it, Reef Knowledge System, and then it'll be the first hit there. So the Reef Knowledge System is basically all things reef. Is the public face of the Reef 2050 Integrated Monitoring and Report Program. So everything reef related will be sitting there, and then dashboard will be there. So as you can see right on the front page, when you go to the landing page of the Reef Knowledge System, you can click on the dashboard and take it there. So basically what I'm going to do now is just introduce you to dashboard. The dashboard's not live yet. As I said, we're still phase one. We're still looking for feedback from our partners and from internally for Gabrumpa as well. But we do have the mock-up of the dashboard that we are able to present, and that's not going to change much over the next few weeks. We are, I think maybe that's just me. I would like to have it up pretty soon, but we're working very hard for that. But we still.
She kept that piece of information till now.
I said that's my desire. That's not everyone's desire. But yeah, we want to have it ready relatively soon, especially to get, use the momentum from the symposium. And also I'm going to talk you through what kind of information you'll be able to see when you go to the dashboard once it's ready to be publicly available. So as you click on the dashboard, as I said, and nothing is live yet, but there will be an icon with the MMP dashboard there. And when you click there, you'll be able to see this page. So before you're actually able to see the dashboard, when you scroll down, there will be a blurb about the marine monitoring program. So basically, just an introduction of what the marine monitoring program is and what it does, and also what kind of information you'll be able to see with the dashboard. And as you scroll down, you'll be able to see this interface. And as I said, this interface, the content will grow as we develop the dashboard, and we get feedback from people, kind of information, as I said, people are interested in. So this will be what we call the, do I have a pointer? Yes. Oh, cool. So this is the overview. So this is just, you see very basic information about the program. So as you can see, site samples by year, along the life of the MMP. You can see here the 3 programs, how long we've been going for, how many sites we survey across the reef. You can see there's a lot of sites, of course, across all 3 programs. And as you can see here, there was a spike in number of sites sampled by the water quality programs, is the dark blue bar over there. And this is actually when we had our independent review. So the MMP is reviewed by independent experts. So we know that what we do here is very sound. And then you have a list of sites locations, and then you can pick out your program and the region where we monitor that particular program. So for example, corals here, I'm just gonna use coral as an example. And then you can see all the sites that we monitor coral along the GBR. So yeah, and the same thing. So it changes just for the core programs, the sites that they service for that particular program, and then again, specific list here. And then if you pick a region, I think I selected different, yeah, the Burdekin, and then you zoom in to the Burdekin region, which is where we are at the moment, here in Townsville, and the number of sites, how it varied along the, the life of the program. And another basic information you can get when you land on this overview page is when you hover over those little dots, you get very basic information like long, the name of the site, and the depth that the coral team surveys corals. So this is very basic things about the program. And then people are going to come here to see, data. Okay, very cool. But so the next thing you can do, you click here on this icon, Reef Scores. And this is the main product that MMP releases every year. The MMP is part of the PADA program, as Kay brilliantly explained. And then we provide data for the Reef Report card. So we also report on those scores. So one example that I picked was the seagrass program. So when you click on the Reef Scores, you're able to pick which program you want to have a look at. So I selected seagrass, mostly because seagrass, in terms of seagrass index, that tell us, the health of the seagrass meadows in the Great Barrier Reef, inshore reef, is a simpler index. So I selected here, when you go to the page, you see a little blurb of what the seagrass condition index is and what kind of indicators inform the seagrass index. And then you can select the region. I selected here again, Burdekin, because it's where we are. And we'll zoom in and we'll show you the, trajectory of that particular seagrass index. So that will be the first graph for all of the programs that you see. I don't have the latest report results yet because Len will be presenting this today, so I didn't want to spoil the news. And below the seagrass index score, you get the two indicators, as I said, that actually inform the score, which in this case is abundance and the resilience score, and how it changed over time. So when you hover over this line here, which is the medium and the upper and the lower range of the index and in the case of the indicators, you get the specific number. And in the future, we will put also what that actually means. So what we want to do is to create a little blurb of, just what it means in terms of the latest results, and to have a little bit of interpretation. But the main idea is to have just, the data out there, and very little information, because all the detailed information will be in our reports when it finally comes out. It's supposed to be a dynamic place. As I said, it will evolve with time as people are interested in more or less data or results coming out from the MMP. One thing that I really want to stress is what the dashboard actually is. It's a scientific communication tool. It's mostly a data visualization tool. What is not is very important, because we get that question quite regularly now that we're developing the dashboard. It's not an analytical tool. No one will be able to manipulate data or results when they go to the dashboard. The dashboard will present data as our partners feel comfortable for us to present, which is basically the graphs and the results that you will find in those reports, but in a more timely manner. And it's not a place where you'll be able to access data. That will be available eventually through the risk knowledge system, but through another, from the back end of the risk knowledge system to another, program, software, whatever. So that's it. And that's very important, because people, when they go to dashboards, they like to tweak and play with that. And it's not going to be possible in terms of the MMP dashboard. And so, as I said, it's a place that we want to have the results in the, out more quickly, especially before the wet season or before summer, where hazardous information can be relevant to management decisions. And we are looking for feedback. So if you think that you've read the reports and you think, oh, I would like to have kind of information up, if that's possible or not. In the future, we want to have, satellite images, because we do event monitoring, and we often circulate when our partners are in the field collecting samples of those big flood events, and we circulate internally and also externally to our stakeholders, those flood plumes entering the Great Barrier Reef, and they're very powerful communication tools. So we want to have that also up. So if the Burdekin is flooding, there will be some information there that we can put up. If we can able to put images, of course, we have to discuss the copyright issues and all that, but if we are able to do that, that will be there. So you can easily see, oh yeah, the flood plume is going all the way to the mid-shelf reefs, and it gives people a better idea what the MMP does as well. So it's not just what we call the routine monitoring, but all those event flooding as well. And more. There is capacity to evolve in terms of the dashboard. And so that feedback is crucial at this stage for us. And as we go, it's not going to be a static thing. It's not going to be rigid like the reports. And we're probably not going to be updating it every week or every month, because those results don't come every week or every month. But to know that we are able to be more flexible in terms of releasing the results than the reports are. And with that, I'd like to thank you all for coming. If you have any questions, let me know.
Questions while we get to the next presenter ready? We're going to go on to water quality. So the first component of water quality presentation is, I should stand up. No. Water quality presentation is going to be from JC Trout Water, Steve Lewis, presenting today. I'm going to see Steve a couple of times. So anyone, any thoughts on the dashboard or anything else that they want to shout out?
And you don't need to say it now, but have a think as well. It's something that people are probably going to have to think about as well. Well, I think so.
Alrighty.
Anyway, yeah, I'd like to introduce Steve. Well, he's presenting on behalf of Jane, who is, where is she again? Can I say it? Vanuatu. Yeah.
When you said she was in the field.
I thought it was MMP as well. I thought she was in the MMP. Anyway. Okay, anyway, take it away, Steve.
Well, good morning, everyone. Thanks for having me today. Kay talked about saying she felt a bit nervous this morning, and I'm a little bit nervous for a different reason, because as Martina just said, I have to somehow fill in for the always incandescent Jane Waterhouse. And I can tell you I'm not going to shine as brightly, but I'll do my very best, so please go a bit easy on me. I'm here to present on behalf of the Tropwater team there who's done all the hard work on the water quality results and really the remote sensing work from the 2021-2022 year. A special shout out then to Christina as well, who we partner with for the Cape York Water Quality Partnership, and you'll hear Christina a little bit later today. So, hang on, does this work or do I have to go off the screen? Okay, I think I've got the pointer working, which is great. So I thought I'd just start the presentation off actually with the reef facts, right? So Kay already touched on the value of the inshore Great Barrier Reef section, and I think this is so important because there's been a lot of misconceptions out there in some sections of the media about, the inshore Great Barrier Reef. There's a lot more coral offshore, etc., etc. Well, the inshore Great Barrier Reef contains a very, very highly diverse part of the Great Barrier Reef. It includes all our tidal estuaries and things like that, enclosed coastal, open coastal sections. And another really neat thing is looking at the actual numbers. It actually hosts 77% of all of the seagrass in the whole Great Barrier Reef lagoon. So, the bulk lion's share of the seagrass meadows, which are so critical for our fisheries, so critical for our dugongs, of course, and turtles, and all that habitat there is held largely within the inshore Great Barrier Reef. And of course, we can even look at the reef area and the coral area. The amount of coral is relatively smaller to the mid and offshore areas of the Great Barrier Reef, but these areas also host very diverse habitats as well. And of course, they're held with some more of our important tourist destinations are also within the inshore Great Barrier Reef. So it is a very, very important area. So moving into the pressures and drivers of this season, and I'll also touch on a little bit of the flood plume monitoring, event monitoring that we did before I really focus primarily on the remote sensing outputs. What did we see this year? Well, starting off with the cyclone activity, with all the hype coming into the season, I was talking that was going to be a very active, above average cyclone season. In the end, the 2021-22 year was quite a bit of a fizzer, really, in the terms of the things. There was the only one system that crossed the coast as a weak Category 1 system was Tropical Cyclone Tiffany, up there in the blue, that crossed up around Cape Melville, Princess Charlotte Bay area. And to be honest with you, I can't even remember Cyclone Tiffany. It seems so long ago now, but that was in sort of early to mid-January this year. The other system of note was Tropical Cyclone Seth, which we probably should really refer to as ex-Tropical Cyclone Seth, because I believe it crossed the Gulf of Carpentaria as a sort of a strong low, but not tropical cyclone strength. It had a passage across, the Gulf of Carpentaria into the Coral Sea area and gave a bit of rainfall for the wet tropics at that area of the Upper Burdekin. And then it sort of moved out into the Coral Sea, reorganised itself a little bit, weakened again, and then curled back around and went into that sort of Burnett Mary region and gave the first big flood of the Mary River for that year. So they're really the two systems of note for that year, but quite a pretty limited cyclone season. In terms of rainfall, this is the rainfall average. This is the long-term rainfall averages here based on the 30-year climatology from 1961 to 1990. This is the wet season in 2021, 2022, and then this is the difference in the climatology. And While you can see there, it looks a little bit drier for the sort of wet tropics, a little bit for the Burdekin region. You can see the wetter area again, though, in the Burnett Mary. I have to just stress here that this record is for the wet season, which is defined as December to April. And as I'll show you with our event monitoring, the big events in the wet tropics and the Burdekin this year actually occurred in May. So that doesn't include that rainfall in May. And if we were to put that in that map, it would come out as a pretty average season for the wet tropics Burdekin area and above average for the Burnett Mary region. But I'll show you the discharge, which gives us probably a better reflection of that anyway in a moment. The discharge for the whole Great Barrier Reef catchment area was just above the long-term median this year and slightly higher than the 2020-21 previous wet season. I guess that doesn't really tell us that regional perspective, which is a lot more important here. So I'll just move straight into that regional data that we have for the discharge from all the NRM regions. What we can see is for Cape York, for this last wet season was just above the long-term median, pretty similar in the Burdekin, just above that long-term median. The wet tropics was just below the long-term median. And poor old the Mackay-Whitsunday region missed out again for probably the second year in a row. Its discharge was about half of the long-term median, so very dry in that Mackay-Whitsunday region. And then as we move further south, the Fitzroy just snuck above the 1.5 times the long-term median. But really the big story this year was the flooding in the Burnett Mary NRM region, which had discharge 8.8 times above the long-term median. But again, actually putting it into that longer term perspective, you can see the 2010-2011 year and 2012-2013 year was actually higher in terms of discharge from that year. But the Mary River had enormous flooding, which I'll get to in a moment. Okay, so just to briefly touch on some of the results from our event water quality sampling. We conducted all our routine monitoring that we do in conjunction with AIMS as scheduled, and we had a bit of a budget to complete 3 flood plume event monitoring trips, one off the Tully in the end of April. Quite a special case in the Horton. We thought we'd have a look at the Horton because a lot of the time the Horton and Burdekin flood together, so it's sort of very difficult to delineate the Horton plume from the Burdekin plume. Well, this year the Horton went that little bit earlier than the Burdekin, so it was like, well, this would be really interesting to go out and just focus on the Horton for a change and do that. So we sampled that in May, and then of course the Burdekin came through a little bit later on and we sampled the Burdekin as well. Plus, I've also got on the bottom there, and I'm really glad he's in the audience, Andrew Moss very kindly sent a team out. Well, he had a team in the field already, and he very kindly collected some extra flood plume samples from the two big Mary River events this year. So we're currently working at that report for Andrew right now, which I'll have to avoid Andrew a bit today because we're still working up that report. Just briefly getting into this is the hydrographs for a few of the rivers now that you'll see. So this is the discharge in megalitres per day and our date for the water year, which the water year is from the 1st of October to the 30th of September. And the red dot is where we conducted our event sampling in the Tully. So the Tully River this year had 3 events above that minor flood level. All below the moderate flood level. There were 3 events and we sampled 2 days after the biggest event of that season, just giving enough time for that water to move out into the Great Barrier Reef Lagoon. The Horton River at Powerline gauge monitoring site, it had 2 moderate size events in this year, and we got out and at that case study sampling was conducted 2 days after the slightly bigger event in that second event of the year. And then moving to the Burdekin site, well, the Burdekin at Clare, The actual downstream Burdekin site, the flood level stayed below the minor level. It didn't reach the minor flood level, but there was minor to moderate flood levels in the upstream tributary reaches of the Burdekin as that water moved down, but it didn't actually get to that minor flood level that BOM classify. However, when you actually look at the volume of water going out there, you can see the peak discharge is, 350,000 megalitres per day. If you look at the previous, Tully and Horton in, minor and moderate floods, they're around that 70,000 megalitres per day. So the Burdekin, even in below minor events, putting out 5 times more water. So still an enormous amount of water going out in those events. We're trying to work up some new products as we ever try to continuously improve our efforts in the marine monitoring program. And we thought, we're collecting a lot of water profile data of the water column. We've got our conductivity temperature depth sensor that's, gives us a profile of that water column, of the salinity, the temperature, we've got a light PAR sensor on it, plus a few extra sensors. And we don't really report that as well as we probably should. So we're starting to think, well, what's a new product we can start using to start visualising this data a little bit better? So this is our first attempt at that. And it's just a shout out to Jane Mallows, who I don't know if she's online. Hello, everybody online. But Jane very kindly in this Burdekin flood plume collected some extra casts for us of the water column. And that's those sort of WP markers there. As well as we sampled all our standard routine and event monitoring sites, which is our BUR codes there. And we plotted a selection of those sites over this colour class map that Caroline made, which is sort of the satellite colour class from that day of sampling. So you can see those different colours, which I'll show you, which I'll go into the remote sensing part in just a moment. But essentially they reflect the different water colours of the more turbid waters, and as we move through, as those flood plume waters are dispersing in the Great Barrier Reef and those changes. So I guess some of the points there, I don't know if you can actually see the numbers, but the KD PAR values of light essentially decline as we move from the mouth of the Burdekin River to the more distal sites offshore, essentially just telling us that, there's more light available getting to deeper parts of the water column, which is probably unsurprising. And the other really neat thing I think this is starting to show us is the mixing of the plume's waters in the Great Barrier Reef Lagoon. So you can see here, the orange line is the PAR profile at that site, and the black line is the salinity reading. So just to point out the salinity reading, so this BUR 12 site, just offshore from the mouth of the Burdekin River, it starts at the surface of about 20 practical salinity units, or PSUs, to 20 salinity. Our actual grab sample at the very surface was about 6 for that year. So our logger actually is a bit more deeper. It starts a bit deeper in the profile because it has to be in the water to, I guess, calibrate itself. So it's just missed that less saline water at the surface, if you like, and you see it mixes down and then it hits pretty much the ocean water, which is a salinity of around 34. So this tells us here that the plume influence at this site is down to about 5 metres depth in the water column. If we move further offshore, say a site at Akron Island, that BUR 3 site, we can see it's a lot, the mixing has occurred a lot greater. The salinity at the surface is now 32, but the influence of the plume in that water column is now down to about 10 metres depth. So we can start to see as that plume's pushing out, it's mixing further and further deeper into the water column. A few flood plume results. I won't really go into this because I know you won't be able to see them particularly well, but just to point out, we do plot things like total suspended solids, nitrate, chlorophyll A, particulate nitrogen and particulate phosphorus over our salinity gradient from pretty much 0 salinity, which is the freshwater end member of the river, all the way across to the seawater end member at about 35 salinity. Those results were fairly unsurprising from previous years. Okay, I'm now going to move into the remote sensing products because this is probably of the most greatest interest to the room, where we can sort of look at these products for the whole Great Barrier Reef and provide our analysis for that whole Great Barrier Reef lagoon. So this is the type of products that we're producing here. We've in the last 2 years, Caroline Pettis, who does all of this work for us as part of the team, we've switched from the old MODIS imagery, the MODIS Aqua and MODIS Terra satellites, to the Sentinel-3 imagery. So this is what a true colour satellite image of the whole reef area looks like. And then from there, Caroline does her magic and converts that to what is now 21 different colour classes that we can pick up from that satellite image, which uses what we call the Forel-Yule scale, which unfortunately abbreviates to the FU scale. So I'll try and say Forel-Yule all the way through. But it's essentially 21 different colour classes, and that is actually compared to what we were looking at with MODIS, you know, the older MODIS satellite, which was up there in the early 2000s, we were only looking at 6 colour classes. So it gives us so much greater resolution of the colours of the water. And from there, Caroline groups them up into different water types. So water type 1, water type 2, water type 3, and water type 4. So what do these numbers mean? Well, water type 1 is really this brownish, really highly turbid waters that we associate with the river flood plumes, that really dirty water that you see at the river mouth, as well as sediment resuspension events in more the shallow sort of, you know, up to 15 to 20 metres water depth. We might get a strong resuspension event that also can create that brown turbid water. And we're calling that water type 1 now. You might have formerly heard us talk about the primary plume waters, and this essentially is now, we're starting to change the terminology to water type 1. But you'll see some of the maps in here, we still say primary, so it's starting to be corrected as we move through. The greenish waters are our water type 2, so this was formerly known as our secondary type waters, and these represent a less turbid part of the flood plume. A lot of the sediment started to fall out. It's still well above the ambient levels that we would expect, and the waters are starting to turn green. The algae is starting to use up the nutrients in the water, and it's quite enriched in the chlorophyll A in those plumes. Then our water types 3 was formerly known as our tertiary waters, and this really represents like a transition from those secondary waters or water type 2 to the beautiful blue Great Barrier Reef waters that we associate the Great Barrier Reef with, if you like. They're somewhere in between. The sediment content or suspended solid concentrations in these water types are slightly above the ambient levels, but there seems to be plenty of light in the water column. And we think these waters really represent a bit of a combination of the remnants of flood plumes in the Great Barrier Reef, as well as other oceanic processes going on, such as, you know, big tidal currents going through the reef, potentially upwelling, resuspension events of the mid and outer shelf reefs and things like that. It's still under an investigation because we're starting to see large areas in this water type 3, and we're still getting our heads around what's causing that colour of the waters. And then finally, water type 2 is these beautiful, you know, blue pristine waters that we associate the reef with, or we were calling marine waters. So moving with this remote sensing, Caroline produces what we call as these frequency maps. So what she does is she compiles all the satellite images throughout the wet season, December to April, and looks at the areas of the Great Barrier Reef that were predominantly in water type 1, predominantly in water type 2, predominantly in water type 3, and predominantly in water type 4. So this gives us the frequency of those water types. And just a bit of a summary for the whole Great Barrier Reef area, we can see, you know, 3% of the inshore waters were in water type 1, and about 17% of the area was in water type 2, which was primarily in the inshore parts of the Great Barrier Reef. When we compare those frequency maps to the previous years, some of our long-term records, what you see is we've got the plots here of what we normally see exposed to water type 1 in a very wet year, in that blue, a very dry year in the orange, and then we see the 2021-2022 years in those black bars. And the other two represent a long-term average from 2003 to 2018, And the 2012, the light green bars, 2012 to 2017, represents what we call like a recovery period for the reef. So if we think back to those times, there was really big flood events in, the late 2000s, early, up to 2011. And then we had a period of lower flow events, which allowed our coral and seagrass to start recovering that little bit better. So we sort of pinned that, and essentially pinned it to there. So what we see with the 2021-2022 season, really the frequency maps are pointing to results, areas under those water types consistent to what we've seen for those long-term averages and those recovery periods. Yeah. Yeah. Sure.
So I just want to understand, so those data are telling me that if you're in a typical wet, say, you've got you've got less than 60% is water type 3, and then you've got more than 20% is water type 1 and 2. So that means about 20% of the waters are water type 3. Is that right? Water type 4, sorry, thank you, Angus.
Water type 4, yeah.
So about 20% of the waters are water type 4 in a typical wet. So that means 80% of the waters are affected by the flood plumes in a typical wet.
No, if you remember, water type 3 is something we're still grappling with on what's causing it. So I'll going to cover that in a minute. So, well, actually it says there.
So marine blue, water type 4 is about 20% of the waters of the marine park for one or other reason in a typical wet.
So water type 1 and 2 is, just over that sort of 20% mark. Water type 3 in a typical wet is just under the 60% mark. So by definition, water type 4 would be around that 20% of the area in a typical wet. But we're still not understanding completely what water type 3 is. So that's the key. It's partly the remnants of flood plumes, but it's also other marine processes that are going on. If there's stronger currents going on or resuspension on that outer shelf, those shallower mid-shelf and, reef crest areas, we're still understanding, and that's what's sort of written there. The larger water type 3 areas above the typical wet, that's happened for the last 4 years now, and we, under both the MODIS and the transition of the Sentinel, we still do not quite understand that well at the moment. And really, I guess the key point is it's really the water types 1 and water types 2 that have that water quality that are likely exceeding the guideline values, which I'll touch on in a minute too. So they're the ones we're most primarily concerned about, which we now will move into. So the frequency maps, we can then create like an anomaly map to compare what the 2021-2022 season compared to that longer term average record. And instead of talking about the whole Great Barrier Reef again, we can start looking at the variations regionally at the NRM region. So we can sort of see here, what we do is 2022, looking at the anomaly map, the areas of more that reddy brown colour are areas below the long-term, water type average for water types 1 and 2. So you can see for essentially the Burdekin, Mackay Whitsunday area, they're below that long-term average. There's parts, and wet tropics as well, sorry. There's parts of the wet tropics in that blue area, sections that were above the typical, that long-term average. And of course, in those wetter areas of the Fitzroy, unsurprisingly, and of course the Burnett Mary, they were above the long-term water type 1 and 2 average. So the next step we can do is take these frequency maps and start looking at what's the likely exposure of these water types and bringing in sort of guideline values. So what we've got now is once we've classified the different water type into water types, when we're out collecting our water quality samples, Caroline can then link the actual concentration we measure in each of those water types and take an average of those concentrations for some of the key parameters that we're interested in. So, you know, for example, total suspended solids, chlorophyll A, particulate phosphorus and particulate nitrogen. And what we can see a general decline in all of those concentrations as we progress from water type 1 to water type 3. And it's predominantly those ones in water type 1 and water type 2 that exceed the guidelines. So Carolyn, through some extra mathematics, will bring in this sort of guideline, this data, and produce like a magnitude score. And combined with the frequency maps, we produce an exposure or likelihood of exposure risk type maps in the Great Barrier Reef. So now we move more to the exposure maps and the assessment for the whole Great Barrier Reef. We see the exposure of those waters. Then we sort of transition it into like exposure risk type. So we have the highest risk, which is risk 4, which is broadly, I think, comparable to water type 1. Don't completely quote me on that. It's probably maybe parts of 2 as well. Risk type 3, the second highest risk, which is still pretty high above guideline values. And then risk type 2 and risk type 1 are of lower concern. But essentially what we get these outputs is it's really the exposure maps are going to sound like a bit of a broken record as I progress through the regions because they're really similar to those long-term averages largely until we get to the Burnett Mary. And then we sort of say 87% of the area was not exposed to any potential risks at all, and only 3% was exposed to the highest risk categories 3 and 4. But of course, I flippantly say that, but when you think about 3% of the Great Barrier Reef Lagoon area, that actually translates to just under 10,000 square kilometres. So it is actually a large area in those higher risk categories. If we look at it like a cross-shelf profile from our like enclosed coastal waters or EC waters to our open coastal, so these are our inshore Great Barrier Reef waters, mid-shelf and offshore waters, you can see primarily those areas of greatest risk are exclusively contained within that inshore Great Barrier Reef for this particular season in risk categories 4 and 3. So a good news year for the mid and outer shelf Great Barrier Reef at least. So if we now move into our regional scale exposure maps and of assessment that Caroline performed, for the Cape York region, 86% of the Cape York not exposed to any risk of these water types, more damaging water types that year or in those categories. 1% of the region was exposed to that highest risk category 4, but there was an increase in about 17% of the corals in the Cape York region that were exposed to that lower risk category 2. And Caroline would like to point out there's a bit of noise in the satellite imagery that she cancels out, but we would just also want to point out some of the really nice data we've got from this flow event from the Annan and Endeavour rivers in April 2022. Just to point out some of these beautiful satellite images we have now of the flood plumes. I know we've had the beautiful MODIS imagery, now we've got Sentinel-2 imagery, which is a much higher resolution satellite. And I'm not sure, I don't know if you can actually see it as well on the screen, but this is before the flood event on the 6th of April. This is after the flood event, and hopefully you can see the really intricate details of this flood plume waters as it moves out over to the mid-shelf of the Great Barrier Reef, over Forester Reef there. Really spectacular images that we're, I love the MODIS images, but these are starting to go to another level again. And Caroline likes to sort of put out these products too, to, the before and after type shots as well, to sort of see that change of extent. So if we move back to how Caroline does that assessments again, this is more the true colour map of the area, upscaling to the Forel Yule colour classes, and then we move that into the water types. And you can see at that particular time of the day when that flood plume was going out there, they were primarily in that water type 1 or primary category waters, and that's more turbid waters. Now, the exposure assessment for the wet tropics, 85% of the wet tropics region wasn't exposed to any risk at all, 1% exposed to category 4 risk. One of the key parts here is we can look at where our coral reef and seagrass ecosystems are, and in that region there was about 14% less of the seagrass exposed to the category 4 type, really turbid waters in this particular year compared to a typical year for the wet tropics, which reflects that slightly below average flooding for that year. And just to go into another couple of Sentinel-2 images that we have for the Daintree River. Again, just really spectacular images of this Daintree River flood plume as it moves out to the mid-shelf of the Great Barrier Reef. You can see those really, I never get tired of looking at these satellite images of the flood plumes. They're just so spectacular as they move offshore. And again, Caroline likes the before and after pics to present like this. And as Kay and Martina talked about, there's such a great communication tool to show that catchment to reef connection in the Great Barrier Reef.
And this can be up within hours.
Yeah. Carolyn can pretty much process these images almost in real time.
That's amazing, the depth of that plume, the colour on the central part of that reaching right out to those reefs that you can see that.
And then again, the Sentinel-3, going back to the sort of medium resolution satellite for that area, that's how those water, they don't look probably as spectacular there on that true colour images, but definitely that, the colour class maps really pick up that plume very, very well, the different colours in there, and they essentially transition up into those water type 1 waters on that particular day. For the Burdekin, again, a broken record, fairly average compared to the long-term average for the Burdekin. Mackay Whitsunday, I guess this is a bit of a surprise. I'm going to say it again. Pretty much very close to the long-term averages in the images. This is probably a little bit unexpected in my head, given that the Mackay Whitsunday region was half the long-term median discharge for that particular year. However, there's other marine processes going on, right, that cause these water types, such as sediment resuspension and things like that. So that's probably dominating in that particular year. Okay, moving on into the Burnett-Merry region and the Fitzroy region, which I'll touch on in a moment. The real story, as I said, of the 2021-2022 year is really in this Burnett-Merry region, which had an 8.8-fold above the long-term median discharge. And in particular, the Merry River, which has a flood gauge on it that goes back to 1910, had the largest total annual discharge on record this wet season, right? So it's the biggest discharge in the 110-year gauge record. And when you look at the actual flow statistics, it was 11.4-fold above the long-term median in that particular year. So just quickly going in the Fitzroy, you can see this is the exposure in the Fitzroy. The analysis there of the exposure maps was that there was slightly more seagrass exposed this year off the Fitzroy region, about 6% more exposed to the category 3 risk type. But again, the story in the Burnett-Merry, and this is, I guess, the key statements here, is that there was a lot more surveyed seagrass exposed to those higher risk categories in that year, about 46% more seagrass exposed to those category 2 to category 4 risk, and about 10% extra of the seagrass meadows were exposed to that highest category 4 risk. So essentially those seagrass had to contend with very turbid waters and probably very low light levels for a very extended period of time. And if we just have a look at some of the images from the Merry River, so this is one of the MODIS images from just around the second big event in the Merry from March. And these were the two major flooding events in the Merry River that Andrew's team kindly sampled for us as well. But incidentally, it was this little blip that occurred in May that just tipped the Mary over the edge to become the record total annual discharge for the year. But and I guess just as again, the colour class map here on the left and the water type on the right on the 15th of January event, again just showing that the plume largely stayed restricted to the coastal zone, the most turbid parts of the plume, but any seagrass along that area would have had very little light for a very long period. And be interested to hear Len's take on the Burnett Merry region seagrass meadows later this afternoon. Some of the other cool products, I just wanted to put this in very quickly, are the loading maps that we produce. So this is pretty much going into the conclusions. So we also produce load estimates for every basin for each year. So with the discharge estimates we have, we know from monitoring there's annual mean concentrations for a lot of the basins that we can then project up and produce a best estimate of the load for each basin for that particular year. And for the parameters total suspended solids, dissolved inorganic nitrogen and particulate nitrogen, we take those loads and we use the e-reefs hydrodynamic model, which shows where the floodwaters go for that particular season. And we essentially disperse that load for that particular year out into the Great Barrier Reef to see where that sort of floodwaters went into and what areas they covered in the Great Barrier Reef Lagoon. The other thing we can do from some of our historic water quality monitoring data in the catchment is we can produce an estimate for that discharge year, what the loads would have been like in the pre-European arrival conditions or our pre-development conditions, and disperse that load out as a comparison, and then we can sort of produce a difference map. So this is the loading maps. We don't have the loading maps for 2022 now, but I thought I'd put up the 2021 season, which was pretty similar, apart from that Burnett Merry region, just to show you what these sort of look like and the exposure of the reef waters to, this is just an example of dissolved inorganic nitrogen. And we feel that this is quite a good communication tool just to demonstrate the areas of the Great Barrier Reef that are exposed to more the anthropogenic pressures of the loads going out there. Okay, so in conclusions, it was a pretty relatively dry and average year for most parts of the Great Barrier Reef from Cape York down to the Mackay-Whitsunday region, a little bit wetter in the Fitzroy and a very much wetter in the Burnett Merry. No major cyclones of notes. As we've talked about, patterns in the frequency and exposure maps very similar to the long-term averages and those coral recovery periods, which is probably a bit of a good news story. Some increase in those turbid waters though that coincide with the areas of the higher discharge in certain parts of Cape York and the Burnett Merry. And we're still getting a better understanding of those physical influences. So I'm sorry, the confusion with the water types 3, but we're still, starting to try to understand that better. And with these new higher resolution satellite images and the extra water quality data we're collecting, I think we'll be able to resolve that fairly quickly as these remote sensing methods get better. Ongoing improvements that we've made this year is we've worked very hard on our river discharge inputs just to refine those so we can get the best data we have on the discharge from each river basin. We've now have 20 years of continuous satellite images for the Great Barrier Reef. The satellite imagery now goes back to 20 years, and Carolyn's working hard to really go back to reprocess a lot of those images, bring in our historic water quality data to try and improve these products even further. And finally, the last big thing of note is we've collaborated with the COTS control team, who regularly visit the mid and outer shelf reefs of the Great Barrier Reef, and they've been collecting water samples for us. Caroline can process the satellite images from those days. And there's also now a phone app called Eye on the Water, where a citizen science essentially type person can take a photo of that water and you get the Foral Yule colour of that water. You can link it with the satellites. And of course, this is pretty valuable, particularly for the cloudy days where we don't have satellite imagery. We could have a lot of photos of the water to get, derived colour classes for those particular days. And it showed that the match up from what the user took to what the satellite images said on the day was pretty much spot on, and the coverage that we got was pretty much the reefs across the mid and outer shelf. So we're starting to get better data now to characterise almost our water type 4 and water type 3 waters now as well for Caroline, which is pretty fantastic. And we're also looking at maybe extending that program to get even more data into the system. So with that, thank you.
Some questions? Any questions for Steve? Oh, you've blinded them aside, Steve.
Oh.
Just stay here with me for a minute. I just wanted to sum up before we go and get some food and beverages. One of the things that MMP did, as I said, was we did a review of where the program was up to, and we talked very intensely with our partners about that. And so some of that funding we've got is to keep doing Carolyn's work with the satellite imagery and keep developing that, because you can see how important that's going to be into making management decisions. The other thing we did too is we looked at some of those components of the green water, maybe, and answering that question. And also one aspect of e-reefs modelling that hasn't been able to be validated yet because we didn't have the technology, and we're now currently supporting a research project and potential monitoring project of trichodesmium blooming in the entire Great Barrier Reef, but the inshore focus, obviously, yet again, trying to answer these questions that we don't have the answers to. And the other thing, it's a perfect example of why we need to monitor. Those incredible rains down south, below where we were monitoring, coming closer to Brisbane and out of those waters, and the comment was, we think we've lost a lot of seagrass. Well, we think. The reason they don't know is because there's not been any monitoring done. There's been no regular monitoring. When was the last monitoring? I think, Andrew, we were talking about that in that region. It was years and years and years ago. So yet again, when these incidents hit, this is when this information becomes critical. And to have this up to date, when things like collisions happen in the Great Barrier Reef, and we need to know what is happening in that spot, we need this sort of information instantly, or bleaching events. So yet again, I'm summing up for Steve how important this monitoring is to the whole Great Barrier Reef management.
There's a comment online from Charlie Morgan from GBF. Great to see the COTS water quality IMR pilot getting a mention, that the data sets are providing valuable. There you go.
Thanks, Charlie.
Any thoughts, questions? I saw food coming in. All right. How long do we have to break? 30 minutes. We've got a long break. Those online, we're breaking for 30 minutes. You'll see a holding slide up while we're breaking. So if you come online backwards and forwards, you'll see when we come back. And time for chatting.
No. Oh, it's working. Hi, everyone. Oh. We're going to resume. All right, so we're going to resume our symposium with Dan Moran presenting the in situ water quality for the AIMS program.
Morning, everyone. I'll give you all a second to sit down. Yeah, maybe. Okay, good morning, everybody. My name is Daniel. I work at AIMS. I work with the water quality team that's responsible for delivering the AIMS components to the MMP water quality monitoring. The AIMS components, we focus mainly on the regions between the wet tropics and the Fitzroy River. But before I start getting into the outcomes from this year and the trends, I'd also just like to acknowledge traditional owners locally here, as we did earlier, the Bindal and Walgaroo people, but also more broadly within the reef regions that we work in between the wet tropics and the Fitzroy, and also further north in Cape York. So today I'll be providing a broad view of the results from the ambient water quality monitoring, and I'll be reflecting on some of the longer term trends in inshore water quality. So this presentation relies on field data that we collect in the field under ambient conditions in both wet and dry seasons. By ambient conditions, and this is different to what Steve presented, but by ambient conditions we mean sampling that occurs outside of the major discharge events. And so we categorize those major discharge events based on river gauges, and so we work outside of those in the ambient monitoring. There's also other components of the program, as you just heard. There's remote sensing and event sampling, which is led by JCU's Trop Water, Jane Waterhouse, and we heard from Steve about that just now. And also Christina Howley leads the water quality monitoring program in the Cape, and they look at event and ambient-based monitoring. And you'll hear from Christina later today, and I believe she'll be also providing some sort of broader perspectives on Cape York. Okay, so as you may be aware, the MMP fits into a reporting and management cycle, which feeds information on the inshore reef into the Paddock to Reef program, and it also supports the Reef 2050 Water Quality Improvement Plan. And today I'll be speaking sort of on our role in this cycle, and as monitors we fit into the middle part, the collect, access and guide section there. So we collect samples which we analyse and produce data, and use that to generate tools that informs management. And the cycle also feeds back around to the monitoring to provide opportunities for improvement, and you heard a bit about that earlier. The point I'd also like to add to this is that the outputs and tools that we generate are also widely used by regional managers and the scientific community more broadly. And we're always working and looking for opportunities to sort of increase that reach and yeah. So for the ambient water quality monitoring, we operate in 5 NRMs regions, the Cape York, the wet tropics, the Burdekin or dry tropics region, Mackay Whitsundays, and the Fitzroy. We monitor in these regions within the enclosed coastal, the open coastal and the mid-shelf water bodies, but most of the sites are in the open coastal water body. The way that the monitoring is structured within those regions also allows us to look at gradients in water quality across the inshore. And we visit the sites within those regions between 3 and 10 times per year, depending on the region. There's different kind of logistical constraints in some regions. And we also have a network of water quality logging instruments within the regions too. So that includes river mouth moorings in most of the regions, and also instruments deployed on reefs throughout those regions. And as you heard from Steve, there is some additional sites that are monitored during events to help categorise the extent and nature of flood plumes. So we've been doing this for a while now, as you heard earlier as well. So the program was initiated in the 2004-2005 wet season. And in 2015, there was a change to the design following on from a review that was conducted with some of our colleagues at CSIRO. And the new monitoring design that was implemented at that time saw us doing more frequent sampling at a greater number of sites. It also included the introduction of the river mouth moorings and additional monitoring efforts prioritised throughout the wet season when we have a greater variability in conditions. The new design increased our power to detect trends in the inshore marine environment. And this year there was another review published which sort of examined that increase in power and capacity to detect trends and showed that that is the case. So I'll quickly just touch on the variables that we examine. They can be broadly categorised into three categories. There's physical variables, which include temperature, salinity, and water clarity. One of the main tools we use for looking at these is conductivity, temperature, and depth profiler, or a CTD. We lower this instrument through the water column, and it collects data between the top and the bottom, which we use then to tell us about the structure of the water column. So whether or not there's layers, or if the water column's well mixed. We also take discrete samples, which we analyse for things like salinity too, which gives us sort of multiple lines of evidence for looking at these variables. And we use other tools in situ, such as the Secchi disk, to look at water clarity. The Secchi disk is a relatively simple tool, but it's one that we like because it's easy to maintain consistency in the measurement over a long-term project, and also integrates a number of biophysical processes that influence some of these variables. We also measure biological variables, which include chlorophyll A and total suspended solids. We do this by discrete sampling, but we also use instruments to measure these variables. The instruments on the left of the screen there you can see are some of those that we have set up to integrate into river mouth moorings. So they measure fluorescence, which is a proxy for chlorophyll, and turbidity, which is a proxy for total suspended solids. The biological variables are important because they sort of tell us about factors that are important to the biology and ecology in the coastal ocean. So obviously chlorophyll is an indicator of productivity within the coastal ocean from things like phytoplankton, and turbidity is related to the amount of stuff that's floating around in the water, and that affects light availability, which is important to seagrasses and corals. We measure chemical variables as well. So those include dissolved and particulate nutrient species, as well as dissolved and particulate organic carbon and coloured dissolved organic matter. So we measure these nutrient species in a number of different ways, including the different forms, dissolved and particulate, organic and inorganic. And we're interested in looking at those because those different forms have different bioavailabilities and different kind of impacts on coastal processes. We are also interested in these nutrients because they potentially can have large impacts on the health of the inshore reef. So they occur naturally, of course, but when we see increases, then there can be sort of negative impacts associated with things like algal blooms when we have increases in nitrogen or phosphorus, and that can impact light availability and have flow-on effects. The data is also used to validate satellite imagery. both within our program, so the stuff you heard from Steve earlier, and also externally. The samples that are collected to inform these analysis are collected by all the various partner organisations, but those samples then are sent back to AIMS and they're analysed in the analytical laboratories there, which gives us consistency across the various partners. Okay, so once we go out and collect the samples, we analyse them obviously, and then we use the data that we generate to create some tools that help us to understand the water quality conditions. So one of those tools is the Annual Water Quality Index. This is been developed to help us visualise trends in the suite of water quality parameters that are measured and help us to monitor water quality and compare it to existing water quality guidelines. So for each monitoring site, the indicators are scored based on their performance against water quality guideline values. For the annual index, the wet season data are compared to wet season guideline values, and the dry season data are compared to dry season guideline values. That performance is then averaged across sites to give site-specific scores, and the sites within a region or sub-region are also averaged to give a regional score, and that provides this sort of time series plot of condition. Broadly, we use this index to characterise water quality conditions in the current year, and we're talking about those water quality conditions in terms of how they're influenced by drivers and pressures that have been important in those years. So we're looking at generally the water quality conditions subject to influences from things like rainfall or wind and waves, tides, and acute impacts like cyclones or floods. We're also interested in water quality trends over years to decades. And so to look at these, we use a couple of different tools. One of these is generalized additive mixed effects models. And these models detrend the data to remove short-term variability from those factors like wind and rain and acute impacts. So it's important, in addition to the GAMs, the models, we also produce a long-term index. And so it's important to distinguish this from the annual index because the design is slightly different. The long-term index is based on the pre-2015 sampling design, and it uses the original sites and also the original sampling occasions. So there's less resolution, I guess, in the data that inputs to these scores, but the focus of them is really on detecting long-term trends. So just keep that in mind when we're looking at those two different index scores later in the presentation. I also just quickly wanted to point out that because the data that inputs into these index scores is compared against the guideline values, it's like a modified amplitude kind of input. And so values that are meeting the guideline values generally are positive, and values that aren't meeting the guideline values are negative. And so the direction of sort of improvement when you're looking at the index plots is sort of up for an improvement in condition and down for a degradation in condition. So when discussing the annual conditions and the recent trends, it's important to consider the drivers. And I'm happy that we've heard from Steve already about this, so he got to give you a bit more detail. But I just wanted to kind of go over them briefly as well. So this year we had generally an average year with overall discharge for the reef slightly below just around the long-term median. But in the discharge plots for the individual NRM regions, you can also see that most of the regions had around median discharge, but there were some exceptions. The Burnett Mary obviously had very high discharge, and also the Mackay-Whitsundays region had about half the median discharge. So I'd like us to try to remember these recent patterns in discharge as we talk through the outputs this year. We can refer back to this slide if we need to, but the main takeaway message, I guess, is that it's been a pretty sort of median average year in terms of discharge and the impacts of that. But in addition to that, besides the acute impacts this year in the Burnett Mary, the high discharge, and also around the Townsville floods in the Burdekin region back in 2019, there's sort of been very few high discharge years over recent years. It's been pretty average conditions in terms of discharge for a number of years now. Just some summary information. Okay, so before we get into the regions, I just thought it'd be good to have a bit of a quick summary as a whole, just so you guys can kind of see where we're getting into. So for the regions that we're monitoring as a whole, generally when looking at the performance of the key indicators against the guideline values, we saw that there was a bit of a mixed bag. There was quite a few areas that had those variables meeting guideline values, but many that weren't. And there were some guideline variables, some variables that were not meeting guidelines across all of the regions. So those included NOx and Secchi disk depth. I'll have a sort of summary for each of the regions for the performance against guideline values. And I'll just quickly go over the shorthand at the top there. Chlorophyll A is obviously for chlorophyll A. NOx is inorganic nitrogen in the form of nitrate and nitrite, so an addition, like a cumulative score or value there. PN stands for particulate nitrogen. PO4 is phosphate, so phosphorus in the dissolved form. PP is particulate phosphorus. The Secchi is the Secchi disk depth, and TSS is total suspended solids. So broadly though, within the reef, the annual water quality index scores were good or moderate for all regions in the 21-22 year. And this was after a generally moderate discharge year. But also importantly, it was after a somewhat unseasonal dry season where we had quite a bit of rain influencing some of the regions. And that's important when talking about the annual index score because of that comparison to seasonal guidelines that I mentioned before. Encouragingly, we saw improvements in the long-term index scores pretty much in all of the regions. So we'll have a bit more of a look at that shortly. And also in the 5-year trends analysis that we do, which is based around the GAMS, we saw that many indicators were either improving or in stable condition. So we'll start in the north and work our way south. So for the Barren Daintree region in the wet tropics, the performance against guideline values was quite good. We had chlorophyll A, particulate nitrogen, phosphate, particulate phosphorus, and total suspended solids all broadly meeting the guideline values, with NOx and Secchi disk depths broadly exceeding those values. The index scores for the Barren Daintree, the annual index score was good this year, which is somewhat consistent with the last couple of years. And the long-term index score was also good. And that long-term index score this year is following a trend that we've seen in recent years of improvement in that region, which is also encouraging to see that trend sort of continuing on for a number of years now. We can also look at some of those trends based on the GAMS, and I've put the GAMS up for the key sort of inputs to the water quality index scores. So we plot these GAMS and we can look at trends over the life of the program, but we also do a 5 years trends analysis where we look at the scores from the GAMS and also the confidence intervals. And we can then look at the ratios between those scores over that 5-year period, and this gives us the opportunity to comment on any statistically relevant changes that have been occurring in that time. So based on that 5-year trends analysis for the Barren Daintree, we saw an improvement in condition for chlorophyll A, particulate phosphorus, and TSS and Secchi, which are the water clarity constituents. We saw stability in particulate nitrogen, which is consistent with the trends that we've been seeing for that parameter over the life of the monitoring program. And we saw a slight degradation in the condition for NOx, which is also consistent with trends that we've been seeing previously. Quickly, before we kind of get into all of the regions, I'll just provide some definitions as well for the GAMS. So the blue lines in the GAMS are a smooth trend based on water quality sampling data. The red lines are a smooth trend based off instrument data. You can't see any red lines in here because we don't have instruments in the Barren-Daintree region, but you'll see them in the subsequent regions. The dots are the modelled data, and the dashed lines are the representation of the guideline values. What I'd like us all to be aware of when we're looking at the GAMS is that these are plotting the data. So generally, an increase in values is indicative of an increase in concentration for some of those variables, which indicates a degradation in condition. So different to the index plots, that increasing sort of value actually indicates a degradation in condition. The only exception to this is for the Secchi disk depth, where an increase in the value is actually indicating a greater depth to which the Secchi disk is visible, which is indicating an improvement in water clarity and an improvement in conditions. So just keep that in mind when you're looking at the plots. I've also added these icons, so that should help you to visualize the trends for the GAMS. So the Russell-Mulgrave is the next region to the south in the wet tropics. The general performance against guideline values for the Russell-Mulgrave, we saw chlorophyll A, phosphate, particulate phosphorus and total suspended solids broadly meeting those guideline values, and NOx, particulate nitrogen, those nitrogen forms were broadly exceeding the guideline values for that Russell-Mulgrave region, and the Secchi disk depth was the same. The index scores for the Russell-Mulgrave, the annual index score was moderate, and the long-term index score was good. The trends in the long-term index are interesting for the Russell-Mulgrave. You can see that the score has been good over the life of the program, but there's been this steady degradation in condition. But that degradation, that trend in degradation has been sort of changed this year, and we're seeing this improvement. So it's really encouraging to see, despite the good condition, that direction of the trend is changing in the current year. When we look at the GAMS for the Russell-Mulgrave and the 5 years trends analysis, we can see that there's a trend for improvement in condition for chlorophyll A and particulate phosphorus. You'll notice on the particulate phosphorus plot there, I've put two icons. The first one is indicating the trend based on the scores, but the second one is showing that based on the 95% confidence interval, that trend might actually just be for stability rather than improvement. The particulate nitrogen trend for the last 5 years is for stability, but this is following recent degradation in condition. So it's encouraging to see that trend has changed. The water clarity constituents are all improving or stable, but have been sort of stable or variable over the monitoring program. And the NOx trend is for stability, similar to particulate nitrogen. We've seen this degradation over earlier monitoring years, but a stabilisation in recent years. In the Tully-Herbert region, the general performance against guideline values show that there's some exceedances for the particulate nitrogen and NOx, and for particulate phosphorus and the Secchi disk depth, but chlorophyll A, phosphate and total suspended solids were broadly meeting the guideline values in the Tully-Herbert region. Performance of the index scores, the annual index this year was moderate for the Tully-Herbert, and the long-term index was poor. You can see a slight degradation in condition for the annual index compared to last year's, remembering subject to annual conditions. Although we had that moderate year this year with discharges, as Steve sort of stated earlier, there was those unseasonal discharges within the wet tropics region, which is likely influencing the annual scores. The long-term index is following a trend for stability, in the Tully region. So that's good to see that there's sort of this stabilisation in condition and not further degradation. The GAMS for the Tully-Herbert region and the 5 years trends analysis are showing that we've had an improvement in condition for chlorophyll A and particulate phosphorus. Particulate nitrogen has degraded over the last 5 years. The water clarity constituents are somewhat stable or slightly improved. And the good news story that I think we can sort of look to in the Tully-Herbert region is that although NOx is exceeding the guideline values and has been in this region and lots of the regions for a number of years, this trend for degradation in condition of NOx seems to have turned around, and we're really seeing this improvement in condition. So yeah, we're keen to sort of keep an eye on that and see how it travels moving forward. In the Burdekin region, we had chlorophyll A, phosphate and particulate phosphorus generally meeting the guideline values. The nitrogen, NOx and particulate nitrogen generally not meeting those guideline values locally, and the water clarity constituents, SECI and TSS, also generally not meeting those local guidelines. However, the index scores are showing for this year the annual index as moderate, and the long-term index actually as good, following a number of years recently where we've had moderate scores. So that good is obviously an indication of improvement. We can probably broadly link that to the generally good conditions we've been having. If we look at the GAMS, you can see, based on the 5 years trends analysis, that there's generally been improvement in the chlorophyll A, particulate nitrogen and particulate phosphorus. But also broadly, there's been stability in the water clarity constituents, perhaps a slight improvement for TSS. Once again, NOx has had that history of degradation, but also this year, based on the 5 years trends analysis, we can see that trend is breaking, and we're having an improvement in condition, actually a slight improvement in condition within the Burdekin region. The Mackay-Witsundays, a lot more of the parameters are not meeting the guideline values in the Mackay-Witsundays, but we are still seeing particulate nitrogen and total suspended solids broadly meeting the local guideline values. The index scores, the annual index is moderate this year, and you can see this sort of improvement on last year. Remembering that in the Mackay-Witsundays we've had quite a moderate year with half median discharge, and that's following a number of years with conditions like that. In the long-term index, you can see an improvement in the score. We've got a moderate score this year, and this is following a slight improvement which we observed and commented on last year, and we're happy to see that trend continuing after a number of years of sort of stable but degraded condition prior to the last couple of years. In the GAMS and the 5 years trends analysis, we can see that chlorophyll A has improved in condition, particulate nitrogen and phosphorus both have improved in condition. The water clarity constituents are broadly stable over recent years, perhaps some sort of variability over the monitoring program. But in the last year or two or so, there's been this sort of uptick in condition, and that's led to a broad improvement in condition in the 5 years trends analysis. NOx for the Mackay-Witsundays region has degraded, as we saw in some of the other regions earlier in the monitoring program, but appears to be stable over the last 5 years. Lastly, the Fitzroy region, similar story to Mackay-Witsundays. We're seeing many of those constituents broadly not meeting the guideline values, but some are, chlorophyll A and phosphate in particular. But when we look at the annual index condition and the long-term index condition, you can see that the condition is generally being categorised as good. The annual index I'm showing here as a coaster format just because of that break in monitoring that we had in the Fitzroy region. It's difficult to sort of draw comments on trends, but once we have more years of monitoring, we'll start to show that time series of the annual index. The long-term index, we've tried to show it in the time series anyway, to also show the historic sampling that happened there. And you can see that despite the break in monitoring, the values or the condition that we're currently seeing is broadly similar to what we saw at the previous conclusion of that monitoring. The same limitations applying to the GAMS, where we have this gap in the monitoring. We've tried to sort of plot the GAMS anyway, although that's somewhat difficult and can lead to sort of erratic behaviour in the tails of the GAMS and influence our capacity to really draw conclusions based on them. But we're plotting them, and the main takeaway message, I guess, is that we're really kind of stoked to be working there again and building that data set so that we can start to sort of look at those trends. So in conclusion, generally this year we saw that the annual water quality condition was moderate or good for all of the regions, remembering that the annual water quality condition is sort of subject to interannual variability, and we had that unseasonal sort of wet season, the unseasonal dry season. The long-term trends, based on the long-term index, we're starting to see signs of improvement in all of the regions. The Barren Daintree has been showing this trend for a number of years, but most of the other regions have been stable and are just starting to see that improvement. It's quite likely that that can be linked to the recent moderate conditions that we've been experiencing over the last few years in terms of discharge and a lack of acute impacts. Yeah, we'd be interested to see how these conditions kind of move forward into the next monitoring seasons. The season that we're just embarking on, so the 22-23 season, I believe, holds a lot of weight. If we have a wet La Nina, which is what we've been seeing down south, then and lots of acute impacts, then likely we'll see degradation. But there is commentary suggesting that La Nina may break. And in addition to that, I think the recent years of favourable conditions will certainly help to build resilience within some of those regions. An example of that is sort of in the wet dry season that we saw, sort of having an influence on the annual scores, but also meaning that the catchments as we come into the next wet season will have good vegetation and good ground cover, and that's going to have positive impacts on fine sediments entering the waterways and making its way to the reef. As per previous years, some of the indicators are still not meeting guideline values, but many are as well. But despite this, you can see in the recent trends analysis that a lot of the indicators are either improving or stable, and so it's like sort of encouraging to see that coming through in the data in those long-term trends. So just wanted to touch quickly on sort of what's next. I guess looking forward, priorities for us firstly are to continue to build the long-term data set. I think that many of you would agree that the utility of this data set to sort of show those trends and patterns in condition is really starting to flourish. And it's important that we continue to build those tools, because as Kay touched on earlier, we can't, if we don't know what's going on when we see impacts, we don't really have any tools to really assess the magnitude of those. We recognise, though, that in seeing these trends, it also raises questions. And so we're also interested in exploring some of those questions and believe that the data we have will be helpful in doing this. So we'd like to explore more on what is driving those trends, and in particular the recent trends. We're interested in the role of climate and coastal processes in this, and also the role of catchments and perhaps the possibility of dividends from some of the catchment management actions that are going on. Lastly, I'll just quickly highlight some information that you can look for on the web. We have an e-atlas page with information about the program, the Water Quality Monitoring Program. The data is all publicly available via the AIMS Data Centre. There's different pages which kind of group the broad data categories that we have, and each of those pages then has a digital object identifier associated with it, which we can use to sort of track use and impact of the data. Of course, I have our annual reports that are on the Gabrumpa e-library, and as you heard from Martina earlier, we're working towards sort of new tools to help communicate the program better, including the dashboard and our data available through the Reef Knowledge System and the RIMRAP data management system, so stay tuned for those. Lastly, some acknowledgements. Obviously, the Great Barrier Reef Marine Park Authority, the JCU Trop Water Team and the Cape York Water Monitoring Partnership, the Reef Trust Partnership for their funding for the Fitzroy monitoring, and also AIMS, the Water Quality Team, and some of the other teams at AIMS more broadly that contribute to our work. That's it. Sorry, what a info there. I tried this year to sort of provide that regional summary, because I know that obviously a lot of people are interested in specific regions. So I hope it wasn't too much information.
We have time for maybe for one question. Oh.
Come on, I'm curious. Just one question. The NOx guidelines seem to be way off for everything.
Yep.
Were they part of the review that you talked about when the program went through it? And what's the relevance of those actual values?
So the guidelines, we haven't set the guidelines. We're just working against them. And they are a bit difficult in some ways. Broadly, if you think about the guidelines as sort of a tool for us to track performance and condition, that's the best way. And you can see that like the scores, the magnitude of the scores is influenced by that performance against the guidelines for a lot of the regions. And so it's hard to look past that, but what we really are trying to focus on is the trends in the condition, and then use the guidelines as a broad goal, something that we can work towards. You're right in stating that that there is this sort of exceedance of that NOx guideline, like in all the regions, and the magnitude of that exceedance is big, and so that's, you can sort of see that in those index plots, those long-term index plots as well, where NOx is sort of way down the bottom of the plot. And so we're interested, in fact, in looking at different ways of modifying or like transforming that data to feed into that. And I was talking to Angus about some of that recently, and our statistician Murray's got some ideas. So.
Hey, don't take it away. Sorry. So you're saying those values, the NOx values, are variants from the guideline values, and because it's vectored in that way, does that have, or how big is the impact on the water quality values and things that come out of that, because it's sitting so far below that?
So it has an impact. But what that also means is that because the sort of influence of that impact is uniform, while it's sitting down low, it sort of doesn't have an impact on the trends that we're really seeing. It's like having a sort of standard impact while it has that sort of high magnitude of exceedance, and the other variables are the ones that are sort of shaping this trend. But what it will do is that if we see this, we're seeing this recent trend in changes to the sort of condition with regards to NOx, and when that comes back into a state where that magnitude is sort of not is being captured back into the index, you'll see that that'll have an influence on the scores. So it's sort of, while it's high, and we're working toward, while it's being like working towards measures to help bring it back, then once that occurs, we'll see an influence again.
Thanks.
Great, thank you. It also brings up another interesting question: is there other factors influencing that we're not currently accounting for? And that's one of the things that we're keeping looking to, is what else might be occurring in that nitrogen arena. So yet again, hence the funding, we're trying to actually ask those questions and find some answers.
Thanks, Ben.
Can't put it in either. I told this, please.
Christina,
You can introduce yourself.
yeah.
Hi, everyone. I'm Christina Howley with the Cape York Water Partnership. I manage the water quality monitoring for the Cape York region under subcontract to JCU. And we do that in a partnership with many organizations in the Cape, lots of local scientists, the traditional owner groups, other conservation groups like South Cape York Catchments, and of course our partners at Ames and JCU and Gabrumpa. So I'd like to acknowledge first the Cape York traditional owners in all of the regions where we work, including the groups that we work closely with who support our field monitoring. So the Yintinga Aboriginal Corporation, the Lama Lama traditional owners, they provide extremely valuable boating and field support, and as well as Rinuru traditional owners and Yukubaja Muluku, and many of the groups to the north as well. And their support is really critical to us being able to do what we do, to be able to access the regions, to know what's going on, whether the roads are even passable, what the weather conditions are like, as well as the value of their knowledge of the country. And to them, it's also quite valuable. The inshore region and the condition of the inshore region is a critical part of their culture and their livelihoods. The hunting and fishing and gathering in that inshore zone is a really strong part of their culture. And so they are continuously telling us how important the work that we do is to them, to see when they see changes, trying to understand what they're seeing out on country. So it's a really mutually beneficial partnership. So I'd like to start by just talking a bit about why it is important that we're working and doing the monitoring we're doing in the Cape York region. There is, I think, some people still have this perception of Cape York being this untouched wilderness, and clearly it's not untouched, but it is a very important region. It comprises 42% of the total reef area and 30% of the seagrass area within the whole of the Great Barrier Reef. The inshore region is still considered to be in relatively good condition compared to some of the central and southern regions. However, before 2007, there was no regular monitoring of water quality in our region, or coral for that matter. And so there's a lot of assumptions being made. And so we really need this baseline data to understand what does water quality look like in our region, and how does that vary between the catchments? It's a huge region, and we have some catchments that are heavily impacted by 100 years of grazing. Most of them are actually heavily impacted by grazing and mining over 100 years, perhaps less intensively than other regions, but the impacts are absolutely there. And some of the catchments are less developed. And so how does this vary? Is the water quality changing? And how does floodwater in our region influence the marine ecosystems? So some of the pressures are the same as what we have elsewhere, but we also have some different situations up in the Cape. So there is large areas of conservation land, and the Annan catchment alone, it's now 80% protected from future development. However, we also have increasing development pressures. There's land clearing for agricultural land use in the Normanby and the Genie basins. There's road erosion, which is widespread across the whole of the Cape on both existing roads and the development of new roads into previously undeveloped areas. We have intense wildfires across the Cape that do increase sediment and nutrient runoff into the rivers and the reef. And we have feral cattle and pigs degrading the aquatic vegetation everywhere, even in the protected zones. We know gully erosion is a significant problem, particularly in the Normanby. The research has been done there to show that the rates of erosion have increased by up to 10 times since the introduction of cattle. And that, of course, leads to increased sediment loads running into the rivers and the reef. That is not just limited to the Normanby. We have that in the Annan catchment and many of the other smaller catchments. Road and track erosion, just to show you some pictures of our daily life in the Cape. This is what our roads look like in the wet season. These are not extreme examples. This is what we drive on. This is what I'm trying to drive on to get up to our monitoring sites. We're starting to quantify some of this erosion, and so the road on the far right corner here, we've quantified using LiDAR or laser surveys before and after the wet season, and showing in this particular example, 80 kilograms per square meter is eroding per year of fine sediment, or less than 63 micron sediment to the rivers, 532 tons per hectare per year for that particular road. So it is a very significant source of sediment that otherwise would not be going into the reef. Fire is another one that's, it's not unique to Cape York, but it is extremely widespread in Cape York. And the research in the Northern Territory has shown these fires in the late dry season, right before the monsoon rains come, they wipe out all the vegetation and they can easily double the sediment load going into the rivers. In other regions, they've seen much more than just a doubling. So we're trying to, again, quantify that and get some numbers for how does sediment impact, or how does fire impact the sediment runoff? But just to see the fire frequency in this, the map in the left corner, every 2 to 3 years, we're getting these extreme late dry season fires. In some regions where you see the brown on that map, that's every year we're getting late dry season fires. So that's every year a doubling, perhaps more, of sediment runoff to the rivers and the reef. So now on to the monitoring that we're doing. We are monitoring for the MMP. We have 4 subregions in the Cape that we monitor: the Pasco River in the north, the Stewart River region just north of Princess Charlotte Bay. So I can use my poker. So that's the Pasco region, the far north, the Stewart River transect, these blue dots right here. Down in Princess Charlotte Bay, we have the Normanby and Kennedy transect. And in the southeast Cape York region, our Ann and Endeavour subregion. So each of these blue dots are our regular monitoring sites that we try to get to 5 times. Most of them we get to 5 times per year under ambient conditions. And then if there's a flood event, we try to get back to these sites to do additional flood monitoring when we can. Of course, because of the roads and just the vast distances and lack of boats in most of these regions, we can't always get there. We've been monitoring in Cape York for 6 years now, so the MMP started monitoring in 2017. We're not yet doing long-term trend analysis, but we are starting to get a nice picture of what's happening up there. And we do use the same methods as Ames and JCU, and our samples all go to the Ames lab, as Dan mentioned. So in addition to the manual sampling that we do, we have 2 reefs where we have the data loggers measuring continuously or every 10 minutes the turbidity, chlorophyll A, salinity, and temperature. Those are both in the Ann and Endeavour region, and we have one out here on Forester Reef, which is about 30 kilometers from the mouths of the rivers, and one right here, the red dot, at Dawson, which is 6 kilometers off the mouth. These complement a wide range of data loggers we have within the rivers. So across the Ann and Endeavour catchment for a separate project, we have turbidity data loggers, so we can actually see how the sediment is moving through the system and how each of these flood events is then influencing when the sediment is actually reaching the reef when we can't get to these sites. So to our results now, so we're not really looking at long-term changes, but Ames has produced these water quality indexes for each year now, and this is just the second year we've done this because it's on the second year Ames has been doing our lab analysis. So this year we had good water quality in the Cape, which we're quite happy about. It was an improvement from the previous year where we had moderate water quality, and we have seen slight improvements in each of the regions over the past year. So I'll go into each of those now. So in the Pasco River, we had moderate water quality overall this year. It was a slightly above average annual discharge year in the Pasco. So, but similar to the previous year, you can see here we're above the annual median long-term discharge in the Pasco region. You can see on the hydrograph in the right corner, the red dots are where we sampled. So most of the rain did come very late in the wet season. In April, we had the major flood. So throughout the rest of the wet season, it was a pretty dry year. And that's probably contributed to some of the improvements that we did see in water quality. You can see that TSS, chlorophyll A, and particulate phosphorus were meeting the water quality guidelines at all or most of our sites. Nitrogen oxides and Secchi depth were not meeting the guidelines at most sites, and the PN and phosphate were mixed at each of the different sites. It was it varied. I will point out that Secchi, you'll see Secchi is not meeting the guidelines at most of our regions, and the Secchi guideline value is based on an annual median, whereas most of our sampling is done in the wet season, so we may be slightly biased in terms of what we're actually picking up with our wet season focus and comparing it to an annual guideline value. Most of the rest of our guideline values are seasonal, so we are comparing wet season data against wet season guideline values. And I also just wanted to point out the guideline values are based on a historic data set from Cape York, so they're local guideline values, even regional local guideline values. So we're not, when we say we're exceeding the guidelines, it's based on a historic baseline as opposed to a specific threat to an aquatic ecosystem. So the Stewart River, we have also a moderate water quality score this year, which was similar to the previous year. We had some improvements in this region as well. There was a much lower river discharge for this year compared to the previous year. And again, like many of the other rivers, we were sitting right around the long-term average or median river discharge. So meeting the guidelines in the Stewart River was chlorophyll A, TSS, particulate phosphorus, and phosphate. As similar to the Pasco, Secchi depth and nitrogen oxides were not meeting the guidelines, and particulate nitrogen was quite mixed. You can see the dots of where we were sampling. We didn't do any focused event monitoring either in the Pasco or the Stewart River this year. We didn't have any huge flood events in the Stewart River, but we were actually out during one of our regularly scheduled monitoring trips. We were picking up some flood impacts from the Normanby River to the south. Those ambient, so the flood event data is not included when we do our scores. So the moderate score that you can see here, any data that's impacted by a flood, whether it's from that river or a river farther to the south, we do exclude from the comparisons with the guideline values. The Normanby Kennedy region was also moderate water quality this year, and that was a real improvement from the previous year where we had poor water quality in the Normanby, so good to see that. We did have less discharge in the Normanby Kennedy region this year compared to the previous year, so that's probably one of the drivers of that improvement. And we had TSS, nitrogen oxides, phosphate, and particulate phosphorus meeting the guidelines, except for our offshore site here at Corbett Reef. Secchi depth was not meeting the guidelines at most sites, and particulate nitrogen and chlorophyll A, again, was mixed between the sites. We did do some event monitoring in the Normanby Kennedy. As you can see on the hydrograph, this site here is when Tropical Cyclone Tiffany passed by, and I'll discuss the event monitoring a bit later. Yes? Any thoughts about why the offshore sites are not meeting? Yes, good question. So the offshore sites, the guideline values for the offshore sites are also based on an annual guideline. So they're lower values that we're trying to meet in that offshore compared to what we're comparing against in the midshore zones. So they're harder to meet, and they're also based on an annual guideline value. So again, we are biased just for that one particular site where we have an offshore water body, and most of our data is being collected in the wet season. So the rest of the sites here are all compared against guideline values for their water bodies, which again are wet season and dry season. And it's really only off in the Secchi depth and that offshore zone where our guideline values are based on annual means or medians. So that's I'm sure that's part of it. I don't know if that's all of the answer. And now the Ann and Endeavour River, we have very good water quality in the Ann and Endeavour this year, so that's exciting. That's the catchment that I live in. and that was also an improvement on the previous year. Very similar discharge, actually slightly higher this year to the previous year, so it's not entirely a discharge story, but the timing of the discharge may be a part of that, because you can see on the hydrograph the majority of or the biggest flood event came late in the year again in the Annan, so we had pretty average, no extreme events through most of the wet season until April, when we had our largest event. Meeting the guidelines was chlorophyll A, TSS, particulate nitrogen, and phosphorus and phosphate. We didn't have any analytes that were not meeting the guidelines, maybe the odd one here or there, but and mixed results for nitrogen oxides and Secchi depth. So yeah, I will point out we did do some event monitoring. We had 2 events that we monitored on the Annan Endeavour, so we'll discuss them a bit later. So our data logger results off at Dawson Reef and Forester, again, this is every 10 minutes. We're collecting samples on turbidity and chlorophyll A or fluorescence. We did meet the guideline, the median wet season turbidity and chlorophyll A concentrations. We're meeting the guideline values at both of those reefs this year. And we've seen at Dawson a consistent decline in the concentrations, reduction in the median concentrations there at Dawson compared to 2018-19, when we had an absolutely huge wet season, a record discharge that year. So it's been a steady decline since then, or improvement in condition. So to just summarize our ambient water quality, we had across most of our sites, chlorophyll A, particulate phosphorus, and TSS were meeting the water quality guidelines. Secchi depth was not at most of our sites, and we had really mixed results for particulate nitrogen, phosphate, and nitrogen oxide, all contributing to this overall moderate water quality that we saw for this year. So moving on to the flood events that we monitored. This was the Norman B. Kennedy flood event in February, associated with Tropical Cyclone Tiffany. So we were out at that point sampling both the Stewart transect and the Kennedy and Norman B. sites. And it was, you can see the flood plume was quite extensive. It covered over 3,500 square kilometers, reaching all the way up past the Stewart River and inundating those reefs up, all the way up into here. You can see the flood waters. However, it was really just a really actually below average magnitude event. So this wasn't a particularly big event for the Norman B and the Kennedy. We sampled over 2 days. We found concentrations around 86 milligrams per liter of suspended sediments here at the Kennedy. It was much lower over at the Norman B on the day that we were there. It was around 10. So we're frequently seeing these higher turbidity or higher suspended sediment concentrations. And you can see that here in this really concentrated turbid plume. And of course, then those concentrations decrease as we get farther north. The chlorophyll A concentrations were also elevated. The average across the year, the median in the ambient is around 0.2, and we were seeing concentrations around 1.2 to 1.5 down in this closer zone, and those concentrations did decrease also as we went up north, but they were still elevated. When we got up to the reefs around the Stewart River, we were seeing concentrations around 0.5 compared to that sort of 0.2 ambient, what we usually see in the ambient conditions. And at the Annan, we saw this beautiful image earlier. We were out monitoring during this flood as well. We had both our turbidity data loggers and chlorophyll A working, and we had 2 boats out sampling this plume, getting as much data as we could. So we were seeing concentrations, the highest concentrations around the mouth of the Annan. At the time we were there anyways, around 74 milligrams per liter for suspended sediments and 36 around the mouth of the Endeavour, and then of course decreasing as you headed north. This plume really somewhat hugged the coast until it got to Cape Bedford, and then it disperses out. And that's why we put this data logger on the Forester Reef, because we often see this pattern where it'll hug the coast and then zip out to these reefs. So what we were seeing was on the turbidity data loggers, it was peaking around 5 NTU at Dawson, and that's pretty low compared to what we've seen in previous flood events where when we have westerly winds and these plume waters go straight out, we'll often see 20 NTU sitting at this reef, but this time it didn't quite hit the reef as strongly and headed up to Forester. And fairly low turbidity, 1 to 3 NTUs up here at Forester over the course of that event, but we saw the chlorophyll A increasing up to around 1.2 at Dawson and sitting between 1 to 2 micrograms per liter over a period of about 5 days up here at Forester Reef. So that's the beauty of these data loggers, is that getting to see how long are these impacts lasting. And you can see just how fluorescent green the water was when we were out there during that event. It was quite impressive. Oops, I'm going over time. So just wanted to acknowledge and say thank you to all of the many people who support the work we do and make it possible up there, including my field team. Eric, who's here in the back, he's our field team leader. Jeff Schellberg, who manages and analyzes all the data from the data loggers. Lana Polglaze up at the Pasco, Sarah Herkus, Pete McKenzie, Brody Gibson, and Jane Mellowers, who we occasionally borrow from down south when we're running short of hands. And of course, the sampling support from the Indigenous groups that we work with, the Ntinga, Rinuru, South Cape York catchments, and Parks and Wildlife will also provide a lot of logistical support for us, and our partners at JCU and Ames, and all the boats that we hire. So thank you.
We have delayed lunch by a few minutes, so we've got time for questions. So it's basically lunch by a few minutes, but we have.
Well, in that case, I'll give Priscilla a minute to speak.
Water means everything. We'd like to thank Grumble for everything that they have done, not only now, but I know in the past when we were doing the turtle management, because we've got a reef out there that needs to be protected as well.
Give her the last word.
Yeah, and that comes from a video that Christina's putting together for us about water quality and the importance to the local community and the TOs in the region. So that we're really looking forward to that final edition from Christina. A couple of notes. Dan, a question?
Hang on.
Thanks.
Sorry, I was just wondering if your traditional owner partners can provide insight into what's been happening over the longer term with water quality, given the relatively recently monitoring?
Well, the types of insights they do provide a lot of insights, probably more so from the rivers, where they can see those changes more easily, and they're concerned. There's a lot of concern about how dirty they're seeing the rivers because of road runoff, and this is something that we're hearing from people across the Cape who are looking at the dirt from the roads and saying, what can we do about this? And so they are seeing those impacts. Probably it's harder, obviously, to see what's going on in the marine environment. We do get reports back about they're having to go farther and farther in some instances to catch turtles. And they're saying, well, what's going on with that? Why are the turtles moving? Are there less of them? Is the seagrass moving? And so those are the types of stories that I hear all the time, and then try to piece together the pieces of the puzzle so we can help them to answer that. But yeah, the marine water quality one's probably a little bit harder.
Sorry, Martin?
I have a question. We often hear that Cape York is a pristine area of the reef, And I would like to know your take on that, if you agree with that statement. No. Okay, that's what we usually tell everybody. It's like, no.
Now, as I discussed, there's quite a lot of the pressures are somewhat different up there, and they're not being picked up in the models, things like fire and road erosion. And so we're constantly being given a low risk status and low priority for investment. And it's just not giving an accurate picture of what's happening up there. And I would like to think that our reefs are in healthier condition than elsewhere, but that doesn't tell the whole story. There's still a lot of pressure up there that we need to actually be quantifying and monitoring better than we have been.
Yet again, it's a dedication thing. None of this monitoring happens without commitments like we see from Christina and all the partners. And that question, thank you, Barbara, segues to something that we were talking about in the break about the use of the dashboard. And we're talking with Rachel and others about how the TO communities would love to be able to see some of this information, see some of this, satellite information of the plumes. They talk about turtles moving, not being at regular beaches anymore, not being where they're finding them, and wondering why and whether this is part of the story. So the other thing we talked about was taking the dashboard out to the paddock to reef with people out on the land and being able to show instantly the farmers and the communities about what is happening, what happens to sediment when it hits that coastline and spills out into the reef. So just thinking, I'm just trying to yet again stimulate some lunchtime thought and feedback about the use of the dashboard. Dan, you had a message on the chat. Nice one, Dan. Great presentation. Wonderful to see a complete monitoring set with the Fitzroy site up and running. Of course, that's from Charlie Morgan. Thanks, Charlie. And yet again, some of that funding that we're coming in is we're hoping to be able to liaise to keep that Fitzroy monitoring running and being incorporated into the MMP. Lots of notes I have and lots of thoughts, but it's lunchtime. You got one? No. That's quickly. Oh, we come back at... For those online, I hope you enjoy your lunch. We're coming back at 1.